A rigid body is rotating with angular velocity 5 radian per second about an axis parallel to 4i cap minus 2j cap plus k cap. So it is given that the magnitude of the angular velocity of the rigid body is 5 radian per second. Suppose the rigid body is moving in the plane of the paper, angular velocity is perpendicular to the plane of the paper, and it is given omega, magnitude of the rigid body, omega is equal to 5 radian per second, and the rigid body is rotating parallel to this vector, that is 4i cap minus 4j cap plus k cap. So if you find out the unit vector of this vector, that is n cap, suppose this is the unit vector n cap. If you find out the unit vector, then you can find out the angular velocity, because angular velocity is equal to omega into the unit vector. Omega is given 5 radian per second, and unit vector you can find out because the vector is given, this vector is parallel to the angular velocity vector. So for unit vector of this vector, you can find out like this: the vector divided by its magnitude, that means 4i cap minus 2j cap plus k cap, divided by magnitude of this vector, 4 square plus minus 2 square plus 1 square. So that is equal to 5 into 4i cap minus 2j cap plus k cap divided by 4 square is equal to 16, and minus 2 square 4, 1 square 1. So you can calculate the value, that is equal to omega is equal to 5 into 4i cap minus 2j cap plus k cap divided by square root of 21. In this way you can find out the angular velocity. But in the question it is given to find out the magnitude of the velocity, magnitude of the linear velocity we have to find out, and it is given that the rigid body is rotating about a vector parallel to this through a point 2i cap minus j cap plus k cap. Suppose this is the point, 2i cap minus j cap plus k cap, and the position vector of this point, let us say r1, and you have to find the magnitude of the velocity of the point of the rigid body at 2i cap minus 2j cap, 3i cap plus 2j cap minus k cap. Suppose this is the point P2, this is the point 3i cap plus 2j cap minus k cap. So the position vector for this point, let us say, is equal to r2. The position vector is r2. Then you can find out the difference between the two vectors, that is r2 minus r1. r2 minus r1 will give you r vector. So if you find out r vector, and if you take the cross product of the angular velocity with the position with this r vector or the displacement vector, then you can find out the velocity. So to find the displacement vector, you calculate like this: r equal to r2 minus r1. You calculate like this: r is equal to r2 minus r1. r2 is 3i cap plus 2j cap minus k cap, minus r1 vector is 2i cap minus j cap plus k cap, 3i cap minus 2i cap. So it is I cap plus 2j cap plus j cap, that is 3j cap, minus k cap minus k cap. So this is minus 2k cap. So you can find out the velocity vector. To find out the velocity vector, you take the cross product of the angular velocity vector with the displacement vector. Angular velocity vector we have found out, that is equal to 5 divided by square root of 21, 4i cap minus 2j cap plus k cap, and displacement vector is I cap plus 2j cap minus 2k cap. If you take the cross product, you take the determinant. So 5 divided by square root of 21, and determinant of this cross product I-j-k. Here the coefficients 4 minus 2 1, so 4 minus 2 1, here 1 3 minus 2, so 1 3 minus 2. So if you take the determinant, then this will be equal to 5 divided by square root of 21 I cap plus 9j cap plus 14k cap. Then you find out the magnitude of the velocity vector, linear velocity vector. The magnitude of the linear velocity vector will be equal to 5 divided by square root of 21, and magnitude of this vector is 1 square plus 9 square plus 14 square. So 1 plus 81, 14 square is 196. So 5 divided by square root of 21, and if you add it, this will be equal to 278. So 5 into 278 divided by 21 square root. So 5 into, if you divide 278 divided by 21, that will be equal to 13.2. So 13.2 square root. So 5 into 13.2 square root is 3.6. So the answer will be 18.1 radian per second. So in this way, you can find out the linear velocity of the body or the particle moving with angular velocity 5 radian per second.